So this chapter is about acid and bases. So the first thing we will need to know the definition of acid, alkalis, alkalis, whatever you read it as, and bases. So then you have to say that you have to recognize them in the type of ions they produce when they are dissolved in water. So you also need to kind of know how these two things affect the universal indicator. So we have these two things now. So the focus of acids is you must know that it is a substance that produces hydrogen ions when dissolved in water. This is a key. If this is not mentioned, you probably get nothing if they ask for a definition. So when dissolved in water, that's another thing. So in aqueous solution, they must produce H plus. So because of this H plus ions, that means every acid will contain hydrogen H plus ions. Then you have like certain examples like the list below. I have hydrochloric acid, I have nitric acid, I have sulfuric acid, and ethanoic acid. Just for the sake of knowledge, these are strong acids, these are weak acids. This is a weak acid. Then strong acids are usually mineral acids. Of course, they don't make sense right now. Mineral acids are those that you find them in your lab. Weak acids can be organic acids. Organic acids is for you is in Sec 5. You will learn it again. Then organic acids or these weak acids are commonly found in the food you consume. So for example, this ethanoic acid, right? This is actually, okay, is there anything you want to express? You have to remember the formulas for balancing equation later on. Then they might ask you to explain why these few substances are acids. So you would have to tell them that when dissolved in water, hydrochloric acid produces H plus ions and Cl minus chloride ions. But the whole point is, if they say, explain why hydrochloric acid is an acid, then you have to say when dissolved in water, HCl produces H plus ions. Same goes for vinegar, same goes for nitric acid and sulfuric acid. When they ask why are these two acids, then you have to say that when dissolved in water, they produce H plus ions. So, a more detailed explanation down here. So you have the hydrogen, oops, sorry. You have the hydrogen chloride or the hydrochloric acid molecule. So when you dissolve it in water, these two will break up and become like that. They go their separate ways. Then for nitric acid, the two will become separate like that too. So the key is this. And then sulfuric acid. One sulfuric acid, this sulfuric acid on its own, when it dissolves in water, it breaks up to form two hydrogen ions and one sulfate ion. So that you must know. Then if you have ethanoic acid, it breaks in a more special, it breaks in a special manner. That means only one hydrogen gets ionized. Then the rest of the 3 hydrogen stays inside. So this does not ionize. So it becomes separate like that. So all of them will produce hydrogen ions. So then I have a question down here. So do all compounds that contain hydrogen, are all of them acids? So they are not. Some of them are not. So like things like compounds like methane, ammonia, or this, all of them contains hydrogen, but then when they do not produce hydrogen ions when they dissolve in water. In fact, let's do some recap down here or revision. Let me ask you, why does methane not dissolve in water? Okay, this is a revision question. So because it does not dissolve in water, it does not produce hydrogen ions. Ammonia, on the other hand, dissolves in water but does not produce H+. So why does methane not dissolve in water? You can write your answer, type it out, and then somewhere in the open space. Because it is a simple covalent compound or a simple covalent molecule, that's why it does not ionize in water at the simple covalent molecule. Next, so you need to know the general properties of acids. So they have sour taste. They conduct electricity in aqueous solution. Then I will ask you why down here. So you have to explain later. They are corrosive when concentrated, and they turn blue litmus paper red. And then they change indicator from universal indicator to orange or red. Then they are able to react with metals, carbonic compounds, and base or alkalis. So these are the things you need to remember. They are general properties. So in general properties, they can then branch into physical property or chemical properties. So this is only for physical. So this is physical, then these are chemical properties. So in questions, they will ask you for physical, chemical property, or some general property. If they ask for general property, always give the chemical answers, chemical properties as answers. Okay, so back to my question, why do acids conduct electricity in aqueous solution? Need help? No, I have not been to effervescence yet. I have not talked about effervescence. Why do acids conduct electricity? When they dissolve in water, they produce H+ ions. For example, HCl, hydrochloric acid, will dissolve in water to produce H plus ions and C chloride ions. So these H plus ions and chloride ions are mobile. They can move in within the solution. So and this, because they are ions, they can carry charge, so they conduct electricity. That's why acids conduct electricity. Water to form H plus ions, to form ions which are mobile, hence they can carry charge, so they conduct electricity. Hence they carry charge and conduct electricity. So what's a base? What's an alkali? Okay, it's like this. Base and alkalis are related. So they are like the exact opposite of acids. And they react with acids to form salt and water only. So bases are metal oxides and metal hydroxides. So in the table, you have some chemical names and the formulas. So iron 2 oxide, magnesium oxide, copper oxide, lithium oxide, they're all metal oxides, so they are bases. Then bases are usually insoluble, except for those made from group 1 metals and the ammonium ion. Ammonium ion is this ion. So they are a group that dissolves in water. They're soluble bases. So soluble bases, they'll form metal hydroxides called alkali, alkali, whatever you read it. So when you have sodium oxide down here, when you add water to it, then it becomes sodium hydroxide. So this is the base, and then this is the alkali. Then and they produce OH minus ions when we dissolve them in solution. So back to sodium hydroxide. So it's a base that is soluble in water. They release hydroxide ions. So like this, NaOH. In solution, they break up into two, like that. They have bitter taste and soapy feel, and they turn red litmus paper blue. Note the universal indicator color, litmus color. Then they can conduct electricity. The reason for them being able to conduct electricity is same as acids. So they react with acids to form salt and water, and these two must keep in mind. And with ammonium salts to form ammonia, salt, and water. So these are physical properties. These are chemical properties. So same goes if they one physical property, give them the ones up there. If they want chemical property, give the two below. So I'll start with the first question. It says state 6 properties of an acid.
Our taste corrosive turns blue litmus paper red. pH less than 7
Any more?
can conduct electricity. Reacts with metals, carbonates, and bases of alkali.
Okay, we're almost there. This one.
It tastes soapy feel.
Okay.
pH more than 7.
Then
able to conduct electricity in aqueous state.
Some more.
Corrosive reacts with ammonium salts to form ammonia salt and water.
Okay. Ammonium salt. Ammonium salt reacts with ammonium. Sorry again. Ammonium salt to form ammonia, salt, and water. Right? Did I hear you correctly? Any
Yeah.
more?
No.